So I'm going to be talking about building and evolving test suites with Twist. This is the broad agenda. So we're going to be talking a little bit about what the current automation landscape looks like. We're going to be talking something about what does it take to do test evolution and maintenance. I hope the bulk of my talk will really be about a Twist demo. I'll be showing you a few examples of test suites that have been built using Twist. And finally, I'll talk a little bit about Twist's roadmap and where we are going in the future. So where are we at the moment? At this point, I think it's fair to say that for most of the technologies that we use to build our applications, so when we're talking about web applications, .NET applications, Mac applications, we have testing drivers that we can use to test them, right? So at ThoughtWorks, we've had something of a fairly rich tradition of building testing tools. So just to introduce you to some people who have actually contributed, this is a partial rogues gallery of tool authors from ThoughtWorks. See if you can recognize them. So that's Jason Huggins on the left, author of Selenium. He wrote Selenium when we were building our internal timesheet application. Everybody at ThoughtWorks uses some different operating system or the other. And we had to have a tool that works across browsers, across operating systems. And we couldn't really say use IE6 or Firefox or whatever else, right? So that's where Selenium was born. That's Ketan Padegaonkar, author of a tool called SWTbot. He actually was with the Twist team for a fair amount of time and is currently working out of our San Francisco office now. We wanted to test Twist using Twist, so that sounds a bit twisted, but we needed to have a way in which we could eat our own dog food, so to speak. And we found, as usual, that the current crop of testing tools at that point for testing SWT applications was fairly poor, to say the least. So we ended up having to build one. That's Paul Hammond, author of Selenium RC. The guy with the wild hair is Narayan. He thought he could do a better job than Selenium, and he wrote a tool called Sahi. Pretty interesting little web testing tool. Part of my demo is going to use a Sahi test suite, and you'll see examples of what Sahi tests look like as well. That's my namesake, Vivek Singh, in the bottom right corner, author of two testing tools for .NET, Sharp Robo and White, both of which can be used to test .NET applications. Simon, who's sitting there right at the back, author of WebDriver. I really don't know who that is. Oh, that's me, author of Frankenstein. Okay, so testing drivers, I would say, at this point, mostly solve the automation problem, right? So we can use tools like Selenium to automate our web interface, for instance. We can interact with web pages. Yes, when new technologies come in, like when Flex came in, it took a little bit of time for tools to catch up and then give us the level of support that we needed in order to test Flex applications, for instance. But invariably, the community does tend to look into that quite quickly. And we do tend to have tools now that can pretty much test most applications. Yes, there are issues sometimes with specific things like file uploads and so on and so forth. But those issues eventually do end up getting solved, right? And we can then start building abstractions. So for instance, if you see the first block that we see right on top, we can say that what we are trying to do is log in to an application. That's a username, that's a password. And finally, we're clicking on the submit button maybe. So we can now pull that out into a method or a function that we now call login with a username and a password. So if we take this one level further, we can build even more abstractions, right? So some of you may know about what we call the page object pattern, where what we try and do is basically encapsulate the business level actions that we're trying to do on a page and put that into a single place. So what that gives us is a nice high level interface with which we can then interact with the application. So what's next? So if we say that the driver problem is partially solved, right? And now we have lots and lots of tests. So what problems do those throw up? So now we are in a situation where we deal with multiple tests, right? So is it valid for us to now think of test suites as a first-class entity? So just a question for the audience. How many of us have thrown away our test suites and rewritten them from scratch? One. Okay, that's much more than I thought. Okay, that's almost half the crowd. Yeah, so why does that happen? Have we ever stopped to think, would we do that to a production code? Yeah? More often? Yeah. Okay, so, but we tend to do it, for some reason, we tend to do it a lot more with test suites. That's been my personal experience, right? So, if you look at tests, functional tests, essentially what we try and do is we tend to have a defined series of steps that we go through. So you'd say log into the system, check whether your account balance is a certain amount, transfer money to another place, check whether your balance is reduced. So it is usually a well-defined sequence of steps. And usually our tests are linear. So I think we're still in the early days of writing our tests. We don't, anybody who's used recursion, for instance, in their test suites or their tests? No? Okay, somebody at the back, that's Simon. Are you talking about WebDriver or your tests? Okay, going on. Some of us like putting together tests with branching. So let's say that this is a test that says, what insurance premium should I pay if I'm a user of a certain type? So if we say that this is for professionals between the age 18 to 60 maybe, assuming that's 60, the retirement age, that's the sequence of steps that you have to go through to do a premium calculation if you're less than 18. And that's what happens if you have to go to someone who's more than 60, right? So you could have branching in your tests, but what some of us prefer to do is to say that those three things are really three different scenarios, and that actually simplifies the way that we look at tests quite significantly, right? So again, when we look at tests, we may see patterns that repeat themselves. So we may have the same series of steps that we do, possibly with different data right down there. So what do we do then? We can refactor our tests, pull things out into something common, and just vary the parameters that we pass into that. So this is what we tend to do a lot when we build test suites. Of course, there are other things that you can do. You can layer them. For instance, you can take care of logging, database abstractions, exception handling, and all of these kind of things. But what I'm really getting at is that the way that we write our tests tends to be linear, fairly well-defined, and there is a fairly small set of refactorings that we can use when we are talking about building evolving test suites. Okay? And of course, that's the equivalent of a function or a method, which can take in parameters and can do whatever it is that we'd like to do. So once you get to a reasonably sized test suite, test maintenance and evolution becomes a fairly significant problem, right? Oops. Yeah, especially when the test suites tend to grow large, and getting the abstractions right is crucial. So again, coming back to the page object pattern. So let's say that we had a banking website. An example of what you could put into a page object for your bank account could be check the balance, transfer your funds, say a request for a loan. You could ask for an annual statement. So this is what I meant by high-level business actions. Now, even if the user interface of the application changes, or if the bank comes up with, say, an Android application that allows you to access your bank account, the test or the page object abstraction is still valid. You would still want to check your balance, you'd still want to transfer funds, and so on. So if you combine multiple pages, you could create a new abstraction that you could call a workflow. So you could check your balance, transfer some money, check your balance again, and that's how you could figure out whether, say, your transfer went through successfully or not. So another problem that we tend to face is collaboration across roles. So what usually ends up happening is that when we put together our test suites, those test suites are really understood only by technical folks. So if you're working in an agile context, for instance, and we have, say, acceptance criteria that go with a feature that basically tell you when you're done, there's usually no link, no direct link between the acceptance criteria and your functional tests. So for instance, if your features are described in a wiki page or a Word document or something like that, someone on the team has to go through the effort of translating that into an executable test. I'm not saying that all teams work in this way, some teams do, right? So we have a representation problem. Typically, our tests are not in a form where non-technical users can understand them and participate in them. So once they end up getting translated, it's very difficult for someone to look at what it looks like. So good luck trying to ask your domain expert or your business analyst to understand what's going on here. Once it gets to this form, it's very hard for them to really participate in the whole testing process, right? So how do we evolve and maintain our tests? I would say that refactoring is part of the answer. So what is refactoring? Just a quick recap. We are talking about improving design without changing behavior. In other words, in the context of testing, we are really saying that when we refactor our tests, we design them in a better way. They still do exactly what they were doing before. It's just that they're structured in a cleaner way. which helps us maintain them better. So the intent of the code that we refactor does not change when we do a refactoring. That's a key characteristic, right? So what implications does all of this have for functional testing? So when a functional test changes, the underlying domain concepts do not. So like I said earlier, coming back to my banking example, let's say that the way that we transfer funds from one account to the other changes. So previously, we had to go to a different page, enter the target account number, click on OK, maybe wait for a confirmation, and then go ahead with that. We could have a change which makes the user interface a lot more streamlined, makes it Ajaxy, just allows you to do everything with a single click in a single page, right? So even though the user interface has changed, the act of trying to do a transfer has not. So we're still talking about transferring funds. It's just that we are now doing it in a different way by interacting with the application in a different way, right? So again, the way in which we transfer funds could now be different, but we are still transferring funds, and that's really critical. So when the domain concepts remain the same, the intent of a test also remains the same, right? I'm sure most of you would know what dry means. It means don't repeat yourself. In the context of testing, it really means that it helps when we have one representation of a testing activity in the entire test suite. So for instance, what I mean by this is one place where we define how do we log into the system, one place where we say how do we transfer funds, one place where we say how do you check the balance, and so on. The reason why this is important is because it's really in our interest to minimize the amount of work that we do when our application actually changes. And this is really about fixing a test should require the minimum number of changes. So how do we represent tests effectively, right? One way of doing this is by using something called a domain-specific language. So what is a domain-specific language, and do you need to be Shakespeare to write one? Not quite. So what is a DSL? A DSL is essentially a mini language that's designed to express the requirements of a particular domain, right? It helps involve the whole team, because when you're talking in terms of the domain, it's something that everyone on the team can hopefully understand. How many of you have read Domain-Driven Design by Eric Evans? Just a couple of you. It's an awesome book. What it really talks about is that when you're building your software, it really helps to have a rich domain model and to use the terminology and the language that we use in the domain in the software itself. So when we talk about accounts, accounting transactions, balances, and so on, it helps to have the same concepts being defined in your code base as well, right? It just makes sure that there's no translation loss that happens when the developers talk about accounts and your business analyst talks about accounts and so on, right? So it helps solve the representation problem. So a sneak peek into what we'll see a lot more of later in this talk. This is an example of a twist test for Go, which is a continuous integration product. You'll notice that the language that we use here is highly specific to what Go does. So Go supports something called a build pipeline. You can think of it as a stage kind of build. So you could say that if you're building a software, you'd first compile it, you'd run your unit tests, you'd then run your functional tests, and if necessary, your performance tests. So the pipeline really represents a whole series of things that you do in your build. So this particular test is trying to see whether a pipeline is triggered if a particular user is added to an approval list. In other words, it's trying to see authorization, whether that works fine or not in the context of Go. So the thing to notice here is that the language is extremely compact. Once you understand what a pipeline is, it's fairly clear what this test is trying to do. We're not talking about how to interact with the web page or whatever client that we are using. It's technology agnostic, right? And if Go continues to have the notion of a pipeline, this test would still be valid far into the future, right? So where are we again? If you look at the current crop of testing tools, we actually lack powerful IDEs. Yeah, I know some of you will say, what about Eclipse and IntelliJ and all of that? But do we have IDEs that can be actually used by a team? Right? It's not just about us as developers and testers, it's also about involving everyone. Evolving test suites is still seen as a black art, right? So this is really interesting paper written by Janita Andrea, who's fairly well known in the agile testing community. It's something like serendipity because the time that she wrote this paper was around the time that we were starting to build Twist. And funnily enough, she happened to be talking about the same set of ideas. So the emphasis is mine. We desperately need functional testing development environments that support the same type of capabilities that IDEs do. Right? Why is refactoring important? Powerful refactorings are even more important in the context of an IDE because now you don't have a safety net. The tests are the safety net. So how can we make sure that we change it without breaking the way that they work? So refactoring becomes even more important. So those of you who have attempted refactoring in the past would know that you can't really refactor unless you have tests, right? Because how would you know whether you broke something? So how do you refactor your functional tests in the first place? What tests the tests? We are not yet at that level, right? So with that, I'd like to talk about Twist. It's a testing IDE built on the Eclipse platform. It allows you to test by building testing DSLs. The language that you use in a Twist test suite would really vary from test suite to test suite. In other words, if you're testing a banking application, you could expect to talk about accounts, transactions, interest, transfers, all the kind of concepts that you would have when you're talking about banking. If you're testing an email application, you'll be talking about forwarding emails, adding attachments, and so on and so forth, right? So you'll see examples of this in a short while. What it really allows you to do is to link what I'd call your acceptance test, your high-level, domain-level test, or test intent to the underlying implementation. You'll see why this is important as part of the demo as well. There are several refactorings that are relevant to testing, and I'll be showing examples of them in a short while. So it's built out of Bangalore. We're a fairly small team. We've been building it for close to 3 years now. And it's something that we are fairly proud of. So with that, let me get into a demo. Hopefully this will work. Okay, so what we have here is something that we refer to as the scenario editor. You'll notice that it pretty much reads like plain English, so nothing really technical going on here. Is that visible at the back, by the way? Yep, okay, so let me zoom in a little bit. Yeah, better? Cool, okay. So this particular test suite that I'm showing you attempts to test Mingle. The reason why I've chosen it is because it's a real-world application. Don't worry too much about the application itself. What I really like you to look at is what the test suite is about, how it's written, and how it's actually put together. So Mingle is a project management tool. And like all project management tools, it has a notion of a project. It can be used by agile teams. So its basic unit of work is something called a card, right? And cards can have custom fields that are called properties, right? You'll see examples of how all of that works in a little while. But the main thing is, if I was starting off Mingle development and I said, what's the very first test that I would like to write? Maybe it would start by saying, let me try and create a project and see whether that actually works out or not. Okay. So whatever is highlighted in green is really the test itself, the executable part of it at least. So we're going to start off by saying, let's create a new project with the description test project. Let me change that a bit. We're going to check that the project, once it's created, is listed. And then once that happens, we're going to clean up after ourselves, delete the project. So this particular test will clean up after itself, leave the system in exactly the same state as it was before it ran. That's something that's very useful, because then you can make sure that your tests are somewhat independent of each other. Okay, so let me run this test, and we'll see what happens next. That's if I can find the execute button. One second. This test is going to launch a browser. I'm just going to try and get it over to the right. Whoops, it's flying past right before my eyes. It's tried to create a new project, and oh, that's it. Okay, let me give it one more shot. There we go, logging into the system, trying to create a new project, created a new project, shows up in the list, and that was it. So what this test really tried to do was log into Mingle, create a new project with a description, check that the project exists, and then delete it, right? So what was actually going on under the covers? So let me navigate down to the underlying code that actually makes this test work. Okay, this particular test happens to use the Sahi driver. Twist supports Selenium as well as Sahi and a bunch of other drivers. But I'll just show how this works. So we clicked on a link called New Project. We entered the project description, basically entered the project name, and finally created the project. And that's how it all worked. The way that it verified whether the project exists was to see whether it shows up as a link in the list of all the projects. So what's really going on here? The IDE is actually trying to link what we call a test scenario with its underlying implementation. It's interactive, and I'll show you how that works in a moment. So if I now go to this test and then say, I just press control space, I get a list of all the steps that are available to me across the entire test suite, right? So this is not just stuff that is available in the context of this test. These are all the actions that have been automated across the entire test suite. Now, obviously, that's a fairly large list. But if I know the names of the entities that I can deal with, then that list starts narrowing down fairly quickly. So if I say, for instance, what can I do with projects? You can see that I can just do a couple of things. I can create a new project with a description. I can delete the project. I can check that the project exists. What about something else? So I said that Mingle allows you to work with cards. So if I type the word card, you can see that I can create cards, add comments to cards, add properties to cards, and so on. So what this really means is that if you're new to this test suite, you can actually go in there and very quickly get a feel for what's out there, what's already automated, and what is not, right? So let me now try and change this test. So what I'm going to do is that I'm going to add a new property. It's like a custom field, okay? So on ThoughtWorks projects, some of them track this thing called volatility. I'm not quite sure what it means. I think it has something to do with things exploding. So, oops. Yeah, that's it. Okay. So you can see that the editor pretty much gives me immediate feedback saying that that's highlighted in a slightly different way. It's not yet implemented. So what can I do to change that? I now have two options. I can either stub out the underlying code, or I can record it, right? I'll just show you how the twist recorder works. By the way, from what I've seen, folks who use twist tend to use the recorder in the early stages. It helps them bootstrap their project fairly quickly. But once they start learning the underlying driver APIs, they usually go ahead and write this by hand. Yep. So what I'm going to show you is the recorder. Let's get everything over, and finally you'll get to see Mingle in action. Okay, is that it actually plays back the scenario until the step that I actually want to record. So it's not as if you're recording the entire thing here. You're actually just recording one small snippet. So if you remember, the step that I've added is how do I create a new custom property called volatility. So what Twist has done is that it's executed the test for me until that particular step, and now it's waiting for me to interact with the app. So that's exactly what I'm going to do. So I'm going to go to the project that I just created. I'm going to project admin, to twist, and again, just struggling with the display a bit. You can see that I have a done button right there, and that's pretty much it. So now, I actually have, just a second. I actually have a new implementation, which allows me to add a new property called volatility. So what does it look like? What is the underlying implementation? So let me just navigate down to that. You can see that it's actually gone ahead and recorded some stuff for me. Just a second. So it pretty much did exactly what I was just doing at that point, which is it went to the project admin link. I clicked on a link called card properties. I created a new card property. Not immediately visible, but you'll see that it's figured out that the value that I had in my test, the data that I had in my test, the property called volatility, has actually been substituted out. So the recorder actually understands parameters and how they work, and will automatically substitute them for you. So I've added a new property, and then finally I clicked on the link called create property right there. Yep. So that's pretty much what I did. And yes, nothing to stop you from going ahead and typing this in once you're familiar with the API as well. So one other thing that I can do is that I can actually go back and re-record a step in case something changes. But I'm not going to be going ahead and showing you that. I'd like to show you some other stuff that's related. So one of the things that you'll notice in the editor is, I know that the test actually flew past, but one of the things that happened was that we actually logged into the system. You'll notice that that's not actually mentioned in the test. So where did we actually do that? So Twist supports something that's called a context. The idea behind this is there are often setup-like activities that you need to do in order to run your test that are required for your test to work, but are peripheral to the test itself. So the idea is to be able to do that as part of a test, but in a slightly different way. So what you can then do is have that as a context. You can have any number of contexts. The way that it all works is if you have a sequence of contexts defined right on top, you can log in first, you can maybe have a test project to work with and so on. All of those actually execute in sequence and will tear on after themselves as well. Okay. Another thing that you'll notice is that Twist supports tagging. So let me just zoom out. Right on top, you'll see that there's a whole bunch of tags. Tags can be used in various ways. So you can use them to define all the different domain level concepts that are involved. So in this case, we are dealing with projects, so it's tagged with projects. We can use them for tracking. So in this case, the tags that we have is iteration 3. Maybe this thing was developed during iteration 3. This is part of a regression test suite, and that's why it's tagged with regression. So what do I do with tags, right? So one of the things that's possible is that you can actually use tags to filter your test suite. So if I'd like to now figure out what are all the smoke tests that I have in this particular test suite, I can now get a list of 3 scenarios that have that smoke tag. What this also allows you to do is to run these tests based on the tag from your CI, which then means that you no longer need to maintain, say, 2 different sets of tests, one for your smoke tests, another one for your regression tests, and so on. So you can have one test suite that can pretty much do all of this for you. Another use for tags is to incrementally build tests. So I'm sure most of us would have been in situations where the functionality may have been developed, but the test is not yet ready. You don't want it to run as part of a CI. So how do you actually approach that? So on the Twist team, one of the things that we do is to use a tag that we call in progress. So what it allows us to do is to mark tests that are not yet ready. And then, as part of our CI, we say run only those scenarios that are not tagged with the tag in progress. So that's something that we use internally as well. Okay. So now let's get on to something a little bit more interesting. Okay. So I'm going to show you examples of how Twist actually supports refactoring. Okay. So what I have here is a slightly more complex test. Okay. So what I'm doing here is that I'm creating a whole bunch of cards. So I'm creating a card called first card. It's going to have a property called status. It's currently in QA. I'm going to create another card with a priority called high. And then I'm going to try and see whether when I filter them, do they show up in a list or not. So you'll notice that I'm kind of doing the exact same thing in these 2 steps. It's just that the data is different. So I'm creating a card and then editing a property. Here again, creating a new card and editing another property in this case. So obviously, this is a sequence of repetitive steps. So what can I now do to pull them out, to abstract them to a higher level? So what I can now do is actually invoke a refactoring that Twist supports. It's called extract concept, first card, right? And description as in QA. Okay? So fairly long sentence, but I think that describes what we're just doing here. Let me click on OK, and you'll see what happens. You'll notice that it looks for that sequence of steps across this test and also the entire test suite, right? So for those of you who know the extract method refactoring, this is the equivalent of saying do an extract method across my whole code base. It's something that's actually pretty useful because as soon as you have sequences of steps that repeat themselves all over the place, then you can actually use this to pretty much pull out an abstraction, replace it with a single sentence, which can then be used everywhere, right? So that's something that's pretty powerful. Let me show you another example of a similar kind of refactoring. Okay, it's in a slightly different test suite. So what happens if we get the level of abstraction wrong, right? So let's say that I have a simple login test, and I say, enter username, enter password, submit form. What's wrong with this test? Anything wrong with this test? Anybody? Sorry? Okay. One of the problems with this test is that it's very coupled to the user interface. So it's talking about interacting with the web page. It says enter the username, enter the password. In some cases, you would see tests that actually have XPath in the test itself, right? So maybe this particular test is at the wrong level of abstraction, and it may be better to put the low-level interaction of the web page into the underlying code itself. So maybe what I'd like to do is push this into the code. So that's another example of a refactoring that you can use. So I can say, select these 3 steps, push to implementation. Let me zoom out a bit. What I'm actually doing is a login. That's my username. You'll see that it substitutes parameters again, and password, Yep. So when I actually click on OK, I now have pushed the underlying implementation into the code. So now if I navigate into it, it's exactly what I was doing earlier, right? So I'm entering the username, the password, and submitting the form. But now I've pushed what was kind of polluting my test scenario by talking about how to interact with the application that we are testing and pushing it into the underlying code. So what I'm really getting at is that these refactorings help us modify, improve the design of our tests in case we get it wrong. And this invariably happens. So one of the hardest things to do is to be able to write tests at the right level of abstraction and to know that it's fine. So in our experience, a good twist test typically tends to be really concise and really short. It helps if it's under 10 steps. That's not always possible, of course, but it really helps when it's boiled down to its absolute essence. And in some cases, in case we get the abstraction wrong, it's always useful to be able to pull that down to a different level. Yep. So those are a couple of examples of refactorings. I'll just show you one more, and then we'll move on to something else. So you'll notice that the language that we use for creating cards is a bit strange. Right? So we're talking about creating detailed card. What does that mean? So maybe I'd want to refine that and make it read a little bit better. So instead of saying create detailed card, what I'd say instead is create a card with name. And again, this refactoring applies not just to the test itself, but every single place where it's used. So if I now look at usages, you'll see that, yeah, apologize, struggling with the display a little bit. I'll just try and see what I can do. You'll see that this particular step is used in a whole bunch of scenarios. And I'm just going to pick up one at random. And you can see that one of the things that it does is it actually respects your test data and tries to ensure that whatever test data that you have is still preserved. It's just that it literally rephrases the sentence and reorders everything so that it still makes sense. Now, one final feature that I'd like to talk about is how we can then do data-driven testing, which is if I have the same sequence of steps that I want to do, and I just want to vary the data that we're going to deal with in the context of the test, how would we actually do that? So we can essentially do that by saying, let's create a data table for this scenario. Twist actually provides a little bit of assistance. What it can do is that it can merge duplicates for you and kind of figure out whether you're talking about the same thing or not. So I'm going to ask it to go ahead and do that. Zoom out again. I now have a little table on my right, which basically describes the parameters that I'm working with. So that's the card name that I have right there. So what I can now do, oops, yeah, looks like I did. Okay, let me just give that one more shot. This time I'm just going to make it a little bit faster. I'm not going to go ahead and bother typing in the parameter. That looks like the one. Yeah, so there you go. So essentially what we have now is a little table that has all the data that we need. Let me add a new row to this. By the way, this is, if you've been following what I've been trying to do, this is equivalent to saying add a new scenario, right? So let's say that I just have card 2. I have card 2's description. And other comments. Doesn't matter. So one of the things that I'd like to point out now is that if I select a particular row, you'll see that what this actually does is that it substitutes the data for you. So you can now look at, once I have a new set of data that's in there, what does my test now look like? So when the test itself runs, the report that you get allows you to do exactly the same thing. You can basically click on a row and look at what the underlying test really looks like. Yep. Okay. So what we have looked at is really a whirlwind kind of feature tour of what this allows you to do. So we looked at a few examples of what this tests look like, what kind of style can you use to write them. We looked at what the underlying driver code looks like and how that can work. We talked a little bit about how the autocomplete works, how some of those refactoring features actually help you to build and evolve your test suite, and so on. Yep. One of the things that you'll notice is that there's this little execute manually button in there. So one of the cool things that Twist allows you to do is to use what we call hybrid execution. So Twist allows you to run your manual tests as well as what we call hybrid tests. Some of you may know this as assisted exploratory testing. What it allows you to do is leverage the automation that you already have in order to do exploratory testing, right? So for instance, in the test that I previously had, maybe let me just pick another one. Maybe the comment one, right? And if there's something that I'd like to check. So if I'm just going to add a new step that says explore, you'll notice that it's not yet implemented, but that's fine. The way this works is kind of very similar to what we have previously. It's essentially going to wait for me to provide input. Okay. Okay, so let me just stop at this point and get back to my presentation. Kind of running out of time. Okay, so you saw an example of the mingled test suite. So what does the Twist architecture look like? Essentially what we have is something that we refer to as a scenario editor. You can write your executable specifications in English or pretty much any language that you would like. We have customers who actually write the Twist tests in Chinese, for instance. The underlying implementation mechanics, what actually makes the test work, won't have time to talk about this. So just want to quickly talk about a little case study that we have. Autotrader.co.uk is UK's second largest website. That's what the website looks as of now, right now, if you go there. Basically allows you to put up your car for sale and put in promotions and things like that to sell your car if you'd like to. So the Autotrader team actually went from 6 weeks of testing before each release to 2 days. So they were using a fairly large Twist test suite. They initially started with around 1,000 Twist tests, but then they refactored that down and brought it down to around 100 fairly concise tests, right? So that's the difference in terms of productivity that they were able to get to. Twist is currently used by around 60 folks across 4 teams, across a multitude of roles. So that means business analysts, developers, testers use it. They currently release twice a month with 0 defects. Now I know this is fairly contentious, but that's what they say. Okay, so this is not what I'm saying. Yep. So anyway, so what does the roadmap for Twist look like? So one of the things that we are currently working on is adding support for other languages. So we have support for Java and Groovy at this point, but we are adding support for Ruby and .NET in the future. New refactoring options. So you just saw examples of them. So you'll be adding stuff like being able to inline concepts, being able to inline code back into your tests, if that makes sense, and so on. So just so that it allows you to write your tests in a natural way and then improve the design of your tests if that is so required. Another piece that we are working on is something called test management. It really allows you to have a unified place where you can look at all your testing activity, which means if you've got manual tests, which allows you to run, as well as automated tests, you'd have one place where you can look at a consolidated look at what everything looks like. And finally, load and performance testing. I don't have enough time to get into the details, but this has some pretty interesting implications when you write tests in the style that I just showed you. Okay? So with that, I'm more or less done. So if there are any questions, I'll be happy to take them.
Hey, looks fantastic.
Thank you.
what are the edges of this thing? Like, at what types of scenarios am I going to have trouble automating with the tool?
Okay, so, okay, interesting question. One of the things that you may have understood is that to some extent what you can do in a twist scenario is actually limited by the driver that you use. So for instance, if you happen to be testing, say, an ActiveX control, and Selenium doesn't support testing ActiveX controls, then you're in some trouble. So that's one limitation, and that's really a technology limitation in terms of what the underlying driver allows you to do. One of the things you can do, though, is that you can actually use combinations of drivers when that actually makes sense. So to give you an example, if you want to do something like driver application using Selenium or Sahi or any other driver, and check something like an audit trail by connecting to the database using, say, a JDBC driver, you can actually do that. Because one of the things that I didn't mention is that you can pretty much use any third-party library under the covers for the underlying implementation. So it's not as if it's a closed kind of system. It's a fairly open kind of runtime. It's effectively a Java runtime, which means you can use whatever libraries that you want. So that's one issue, which is a technology limitation. The second thing that we have seen is, and we saw this in the auto trader case as well, when let's say that you're doing something like agile-based development, and you have, say, multiple scenarios for each story, you can rapidly have an explosion of scenarios. So in auto trader's case, they actually ended up with almost close to 1,000, which obviously is a huge number. So another pattern that we have seen is that it's very important to kind of consolidate your scenarios as your test suite starts growing. So if I have a test for login already, and it's being used in a million different places because that's something that I always have to do I really need to have a login test anymore? Right? So some of these things start, once they start getting used more and more in the application, they can now be part of other tests. So is there something else?
Maybe that would be a good feature to add, is that you could automatically tell me where I can eliminate tests.
Okay, that's exactly what the test management piece will do, one of the things.
Okay,
yeah,
thanks.
Cool. Okay.
Looks like it's something like a wiki web server, but I am wondering if we can see the same features or the stuff you showed us. You know, we can get it combining Selenium and other web acceptance web frameworks like Selenium and Cucumber or Selenium or Fitnessy. Don't you think we can achieve the same stuff that you showed us? Of course, you guys have got a better UI.
Mm-hmm.
So,
okay.
What's your take on that?
Yeah. So his question was, can't you use, say, a driver like Selenium along with, say, other frameworks like Cucumber and so on? Yeah, the answer is yes, obviously you can. But one of the things that Twist allows you to do is to look at your whole test suite. So you saw some of the refactorings that are possible. If you're using some of the other tools that you talked about, you would have to do some of those refactorings by hand. This starts becoming important once your test suite grows. So yes, you can definitely write tests in a similar kind of style. But the difference is really in terms of your personal productivity and how long does it take you to make a change when your application changes. In some cases, that becomes really critical, especially when you're talking about software that's released twice a month, where the application is changing really rapidly. The amount of time and effort it takes to make changes to your test suite starts mattering really quickly, right? And that's really something that Twist allows you to do. So again, really the emphasis of my talk and what this is really all about is let's go beyond one test and let's look at the test suite. It's a first-class entity in its own right, and it's something that we probably need to look at in a different way that we have in the past.
Is Twist a open source tool or commercial?
Twist is a commercial tool.
That's the Twist, I guess.
Yeah, it is a commercial tool, yes. Yep.
Hey, Prahlad, this is a beautiful tool, and the refactoring is amazing.
Thank you.
At the same time, one of the challenge generally in the refactoring the code is your data is going to change the scenario. Say, for example, if I've created a table considering the current context, and I would have built table over and over again, and it has grown by itself, right? Okay. And this is beautiful in terms of code refactoring. But when you have to change the data and it has to implement all the functionalities, if I'm right, when you went to each one of these rows, it substituted the same value, but it still went to the same scenario.
Yes, that's right.
Right?
That's right.
If it has to change the scenario, right, which is, I know it's a huge change by itself, right? It is, there is no, but how does the system, or is there a thought in terms of like, whether you're planning to build or you have any solutions, or because that's a common challenge all the time, right?
Sure. That's a very good question. It's kind of related to the branching thing that I showed you right at the beginning. It's almost as if we have one scenario that's actually two scenarios or more. That's one way to handle it. All I like to say is that the data management support that we have right now, or data-driven testing support that we have right now, is pretty much in its infancy. So we are thinking about the problem that you're talking about. One of the ideas was to see whether we can actually talk about data not just as at an overall test level, but almost at a workflow level. So to take one block and see whether it can be written in different ways with different data inputs. That, of course, is a fairly complex way of handling it. It's something that we are still currently working on. Yep. Okay, there's a question on the back.
Vivek, I have a question. So
can you raise your hand, please? Yeah, thanks.
yeah.
Yep.
So Twist, is it an test automation tool or is it a test management tool?
Good question.
Because I'm confused. I downloaded the trial version of both Mingle and Twist. I've been using it for last 3 months.
Sure.
I'm confused when you said you have automated steps and then you can
Sure.
do manual testing also.
Sure.
Additional features are like you are going to put the manual results, automation results. But so confused me.
That's actually a very good question. I think it depends on what your definition of test management is. So the way I look at it is that Twist is a tool that helps you work with your entire test suite. It's one place to keep your automated tests, your manual tests, and all of that, to get reporting on your tests when they execute from your CI, and then to be able to evolve your tests once you move on. Now, I don't really want to get into like redefining or defining test management and all of that. Maybe you can catch up later and talk about it. But really, that's how I would look at it. The test management stuff that I talked about is really about visualization, getting a sense of what is the overall health of your test suite, and being able to interact with the application, not just using this interface that I just showed you, but also via the web, so that you can have one place to look at your test reports, not just for your automated tests as well as your manual tests. So when Twist tests run as part of the CI, you don't need to have the editor installed. You can actually run that from the command line. So that's really what the test management piece tries to do.
One additional question on that.
Sure.
So is it limited to GUI automation or can we do service layer automation also?
It is not. So as I was saying earlier, the Twist test itself runs on the Java runtime. So pretty much anything that you can do with Java code can be part of your test. So you can, for instance, test services if you want to. You can, as I said earlier, interact with databases using JDBC drivers. So pretty much the sky's the limit. The examples of the tests that I showed you, yes, are tied to user interfaces, but it's not necessary that you write them that way. So you can write tests in the fit style if you'd like to, if that's what you're getting at.
Yeah. Thanks.
And thank you again for voting for this talk, and it's a pleasure to be here. So again, if there are any further questions, I'll be available at any point during the conference, and we can talk. Thank you.